Launders Algebra. Happy New Year. This is Mr. Lawrence with your winter break video number 4, if you can reach that chicken scratch of mine. Okay, we're going to be covering Chapter 7. We'll cover a couple topics we already know, and we're going to cover a topic that will help us get ready for January 4th's lesson, because when we come in, we're going to go right back to work. All right, so the first thing that we'll be covering is solving systems by graphing, right? And that'll include equations and inequalities. So let's get right to it. Let's say we have the following two equations, the following system of equations, I should say. Let me get a little room there, get rid of that stray red point. And where is my little cheat sheet here? Let's say our first equation is this. Y equals -2/3 x plus 2. And my second equation will be 3x minus 2y equals 2. All right, I'm going to go ahead and graph these. I'll do the green one first. It's in slope y-intercept form. I have a y-intercept of 2. And I know the slope is -2, +3. So down 2, right 1, 2, 3. Down 2, right 1, 2, 3. There we go. And I can draw my line. Of course, it's a solid line because it says equals. Down 2, 1, 2, 3. Oh man, everything is off. I must need to reorient. Let me do that real quick here. 1 second. Line style. Make it a little bit thinner, and I want it to be green because it's not easy being green. Having to spend each day the color of the leaves. All right, so that's pretty close. Down 2, 1, 2, 3. Okay. Okay, so now I'll graph the red one. I know it's in standard form. I think the y-intercept would be pretty easy to find. It looks like it'll be 2 divided by -2. The y-intercept will be -1. All right, and the x-intercept is a fraction, so I don't want to go with a fraction. I will go with the slope instead, which would be -3 over -2, which simplifies to 3 over 2. So I'll count up 1, 2, 3, right 1, 2, up 1, 2, 3, right 1, 2. Okay, I'll graph it. It will be a solid line, 1, 2, 3, 1, 2, something like that. And I've done a very good job graphing this one. The problem is, you can see the solution. You can see the solution on the graph, but you can't actually tell what the coordinates are of where they cross. But I did do it properly. In a minute, we'll remind us why we do substitution and why we're going to learn elimination. It's because of a situation like this. All right, let's go on to solving a system of inequalities, which you guys have been so good at. Let me get a sheet of graph paper. There we go. And let's have the equation y equals -2/5 x plus 4. And then the other one will be, where's my yellow? There it is. All right, we'll go with 3x minus 4y, and we'll make that equal to 12. Now, I made a mistake here. I don't want these to say equal. I'll make the yellow one be less than 12. Oops, it's not in yellow. Okay, so I changed the blue one to y is greater than or equal to, and I changed the yellow one so there was less than 12. I'll graph the blue one. It's in slope y-intercept form, 1, 2, 3, 4. And then I will go down 2 and write 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5. There we go. Okay, I will draw my line. Now, it is going to be a solid line, right? Okay, it's going to be a solid line. And I should make it fuzzy and blue. Now I have to decide where to shade. Okay, Well, I'll plug 0, 0 into x and y, and I get the statement that 0 is greater than or equal to 4. I know that is not true. So I will shade above the blue line. And I guess I could make that a prettier shade of blue, I suppose. Let's see here if I can hocus pocus, change my focus. I'm afraid that's a little dark, but we'll see if it works. Okay, now I need to graph my yellow equation. It looks like it's in standard form. I think my x-intercept is going to be the point 4. 1, 2, 3, 4. My y-intercept is going to be the point -3. 1, 2, 3. All right. And it looks like I'm going to go up 3 and right 4. 1, 2, 3. 1, 2, 3, 4. So right about there. It's kind of hard to see that. But I'll go ahead and draw my line. This one will be a broken line. And it'll go something like that. And let me see if I can make it look a little bit better. It's broken because it doesn't say equals to, right? And there we go. And I can extend it longer. Now I need to see if it ends up, I got to use a test point. I love to use 0, 0. Remember, the only time I can't use 0, 0 is when the line actually passes through the origin. This time I get a true statement that 0 is less than 12, so I will shade where the origin is. So I'll shade the above the line. And it didn't actually turn green for me, but you can see where the shading is very dark. And that's because of the color I chose for blue, but let me see if I can fix that. Get a different kind of blue in there, and then it'll be a nice pretty green, because blue and yellow will make green after all. Let's see, how does that one look? Ooh, that one looks real pretty. I like it. And there you go. The green region, and remember, this green region goes on forever. It follows this broken line, follows a solid line, and it covers everything in here on forever. Okay, very good. So that's solving systems. Now, by graphing, let's talk about substitution. Okay. In fact, I'm going to use the same two equations that I used in the first problem. So let me bring those equations back. Looks like I had y equal to -2x plus 2. Y equal to -2x plus 2. I think it was 2/3 x, wasn't it? Oh, what's going on here? Trying to scroll. Yeah, -2/3 x. All right. And the red one is 3x minus 2y equals 2. 3x minus 2y equals 2. Now, if I do this by substitution, remember, in substitution, I want to get one of the variables alone. I check all 4 variables and look for the one that's the least amount of work. Well, it's already solved for y in the first equation, right? Okay, so here's what I'll do. I will take this and put it in for y in that equation. So I will get 3x minus 2 times the quantity of -2/3 x plus 2, and that will need to equal 2. So from here I will distribute 3x plus 4/3 x minus 4, right? Minus 4, and that will equal 2. All right, I know that's the same as 1 and 1/3, and I think that might be easier to work with, because now when I go to combine my like terms, I know that I'll have, whoa, I'm not in right mode, pardon me, 4 and 1/3 x minus 4, which will equal 2. I'll add 4 to each side. Now I'm going to convert this back to a mixed number, come up with 13/3 x, that will equal 6. I'm going to divide each side by 13/3, which means that x will equal 6/1 times 3/13. All right, when I do that, I don't see anything that's going to cancel. X is going to end up equaling 18 over 13, or 1 5/13, right? Yeah, I think so. Okay, so that's what X equals. Now I have to figure out what Y equals. Well, the easiest equation, in my opinion, would be to use this one. So I'm going to do Y equals -2/3. I'm going to plug 18/13 in for X. And then I have to add 2 to whatever I get. And you can see this is really ugly. There's no way you'd be able to look at the graph and tell what you're going to get. 36/39 plus 2. Well, I'm almost taking 1 away. Not quite 1, so my answer is going to be 1 and 3/39. But that simplifies to 1 and 1/13. I could have simplified here and then combined the like terms if I wanted. So my answer is going to be 1 and 5/13 for the x coordinate and 1 and 1/13 for the y coordinate. And if I go back and look at the original graph right there, you can see that my x coordinate is a little bit more than 1 and my y coordinate is a little bit more than 1 as well. Okay, my graphing makes me think x might have been about 1.5, 1.5, and actually it's not even close. It's not even 1.2. Substitution gives me an exact answer where the graphing cannot. Okay, now remember, if you have a problem like this to do substitution, you want to solve for the variable that will provide you the least amount of work. It will give you the prettiest answers. I think I would solve for x in the first equation because I know that 2 goes into both 4 and 10 evenly. I won't have any fractions. It'll be 2 steps. If I try to solve for x in the second, I'm going to have to divide 7 by 3 and 11 by 3. I get fractions. If I try to solve for y in the second, I have to divide 3 by 7 and 11 by 7. If I have to solve for y in the first, I'll have to divide 2 by 4 and 10 by 4. That's not too bad to work with, but solving for x in the first one gives me the easiest numbers to work with. All right, I'm not going to do this one right now, but if you want to take a minute to do it, pause, go right ahead. I'm going to pause and my answer will appear in a few moments. Here's my work to solve for y. I solved for x right here. I substituted that in. I solved for y and I got 4/13. I'll go ahead and pause and get x now. I plug it into the x equals -2y plus 5 equation. I get x equals -8/13 plus 5. I know that x must equal 4 and 5/13. So my solutions are 4 and 5/13 for my x coordinate and 4/13 for my y coordinate. And there you go, solving by substitution. All right. Now we have to remember, we have to learn the new type, which is solving by elimination. Okay, and I'm not going to do a whole lot of examples. You get some practice in class with that. Solving by elimination. Let's say we have an equation like this. And 5x minus 2y, and we're going to make that equal to 8 as well. Okay. Take a look at your coefficients on x in both equations and on y in both equations. You see how the y coefficient is a +2 and then a -2? If I go ahead and add these two equations together, what will happen to those y's? They'll cancel out, won't they? Let's go ahead and add. 3x plus 5x is 8x. Those cancel. 8 plus 8 is 16. Look at this. I have one equation with only one variable. I can solve for x. X equals 2. Some of you go, wow, that's the easiest thing I've ever done. I'm going to do it and do it and do it. Careful. They're not always that easy. Sometimes they are. Now, I only have x. I don't have y solved for. So now I need to take that x equals 2 and plug it into either this equation or the second equation. I think I'll plug it into the first equation because the numbers are a little bit smaller, but there really is no right answer there. Okay, 3 times 2 plus 2y equals 8. And I'll solve for y. 6 plus 2y equals 8. 2y will equal 2. Y must equal 1. These 2 points cross at the point, or these 2 lines cross at the point 2, 1. That's a simple version of solving by substitution. All right, I'm going to put up a little more complex version. Let's say I have 3x plus 4y. We'll make that equal to 12. And then I'll have 5x minus 2y, and we'll make that equal to 10. All right, now check this out. Looking at my coefficients, none of them match up. But I do notice on my y's that the 4 is double the negative 2. If I could just somehow turn that negative 2 into a negative 4, I could do what I did on the last problem. It'd be easy. Well, how do I do that? I'm going to multiply it by a 2. But if I multiply there, I'm going to have to multiply this guy by 2 and the 10 by 2 as well. So my new situation ends up being like this. 3x plus 4y equals 12. And then the equation I multiplied by, I'll get 10x minus 4y, and that will equal 20. Now, if I go ahead and add, I will end up getting 13x. Those will cancel, and that'll equal 32. All right, I'll divide each side by 13. Okay, x will equal 32 over 13. Or that would be the same as 2 and 6/13. So just a smidgen more than 6.5 if you're thinking about it. Now I have to go back and figure out what y is. I think I don't think either one looks great. I guess I'll go ahead and use the first equation. So I'll do 3 over 1 times 32 over 13. Okay, plus 4y. That'll equal 12. All right, that'll become 64 over 13 plus 4y equal 12. I might want to turn that into a mixed number here. So it'll go in 4 and 12/13 plus 4y equals 12. Okay, I'll subtract 4 and 12/13 from both sides. I'll get 4y equals, I know 12 minus 4 is 8, but I got to take another 12/13 away, so my answer will be 7 and 1/13. Okay, and then I'll divide by 4. Okay, now at this point, the numbers are getting pretty ugly. If you're going to a calculator, I wouldn't blame you. Let me hide that out of the way. Let me see here. 7 times 13 is 91. So it's really y equals 92 over 13 times 1/4, right? I think that does reduce. 100 would be 25. I think this is going to be 23. Yeah, 23 times. So the answer for y is going to end up being 23/13 or 1 and 10/13. Some ugly answers, but the elimination method allows us to get them. So 1 and 10/13, and then 2 and 6/13 was the other answer. You'd never be able to get these graphing. Okay, we're almost out of time here for this video. I don't want it to go too long, but just look at this really quick. 5x plus 3y equals 7, and 2x plus 8y equals 10. I'm not actually going to do this whole problem, but I want you to look at it. Look at those coefficients. Okay? None of them are multiples of each other. So what I could do on this one is multiply the top equation by 2, and then the bottom equation by -5. Why the negative? Because it'll allow me to get opposite signs. remember, I want the coefficients to match, but have one sign be positive and the other be negative. The top equation then becomes 10x plus 6y, and that equals 14. The bottom equation becomes negative 10x minus 40y, and that will equal negative 50. I can go ahead and add, and those will cancel. I'll end up with a negative 36, excuse me, a negative 34y. 34y, and that'll equal negative 36. Okay, I can solve for y. I guess I said I wasn't going to do it. I contradicted myself. 34 divided by negative 34. So then y will equal, those will cancel. Say I'm going to get 18/17 for y. Then I could go plug it back in. So let me see here. And I'll choose the original equation because it's easier to work with. I will go with 5x plus 3 for 1 times 18/17, and that will equal 7. Okay, and I'll have to solve for x. All right, so 5x. I'm getting tired because it's minutes before Christmas break. Let's see, 454, right? Yeah, over 17 equals 7. I know 17 times 3 is 51, so that'll turn into 3 and 3/17. I'll subtract 3 and 3/17 from both sides. 3 and 3/17. Okay, 5x will end up equaling 3 and 14/17. And then I can take that and divide it by 5. Hold on one moment. I'm going to cheat. 14 divided by 17 plus 3 divided by 5. X is going to equal about 0.76, so right around 3/4. Hold on. And that comes out to be 13/17 on the nose. So the answer would be 13/17 and 1 and 1/17. And there you go. They are ugly. Most of the problems in class won't come out so ugly, but for the video, you can see how to do it. All right. Thank you for watching, everybody. I will see you guys on January 4th. Hopefully you've been keeping up on your math and not letting your skills diminish. All right. Remember, the midterm is January 11th. Goodbye, everybody.